Hello everyone, welcome to tutorial 3. So in previous video we were discussing about time series data set and we left at the point where we were discussing methods. So I quickly scroll to the methods. So I have multiple methods provided to me by PyTorch Forecasting time series dataset class. First one is calculate decode length. So I think you can already read about this one. This is pretty much straightforward. You need to pass time index and sequence. Another very important method which we have is filter. So filter helps us to keep only the subsequences that satisfies a particular condition. So for example, if you want to use it, you have time series data set with you. So you have training data set. This entire data set has a very large length, which is 1074, and I only want where encoder length is greater than 25. So if I use this particular syntax, this should give me error because this X doesn't know about encoder length. So this thing is pretty much obvious that anything we cannot filter upon. There are certain things which we can only filter. The things which we can filter on are these. We can either filter on store IDs, product IDs, time index first, time index last. So this is end to end, and from where the prediction starts, which is 44 in this case, plus 7, which is 50, and first time index is 14. So if I want to filter same thing encoder length, what I want to do is subtract this from where the prediction starts minus from where the first index is present. So if I do 44 minus 14, this should give me same encoder length. So I just quickly copy the same thing and this minus the first time index. It will also do the same thing. If I check filter DS, see it is little shorter now. I can also pass product ID. So if I pass product ID here, store ID I mean, or product ID, whatever I can use, X, suppose I set it to SO as 0, I mean. So it should also filter and it should not be greater than, it should be equal to in this case. And now it is filter and I have only 358 records. Okay, so all good about filter. This is actually very powerful if you want to do predictions also and on a particular store ID or a product ID, you can use this. Second very important method is from dataset, which we have already seen. So when you are creating validation dataset, you can directly import the settings of training dataset in the validation dataset, and you can use the DF as it is. Also provide the time index, whatever you want to pass. Validation doesn't exist. Okay, so you can create validation dataset directly from the settings in the training dataset. Also, if you want to store the settings somewhere else, you can extract the parameters and then create the validation dataset. So if I want to extract all whatever parameters I have passed in while creating the training dataset, I can obtain them in params. Okay, so I have all the parameters. Then if I want to recreate the dataset, I can use from parameter method which I have. So I have syntax right here. These all things help when you are making inference or doing debugging. Okay, so this also works. Now you can also create dataset directly with the settings you have or parameters. Another important method is get transformers. When we were creating the dataset, we also passed some encoders or scalars. And if you want to retrieve them back, we can simply write get transformer thing. So the syntax is already given here. Suppose for price, we use some scalar or encoder. So if I run this, I get standard scalar. So for price, I have used standard scalar. I can also check it for store ID. So for store ID, I used NaN level encoders and all the settings about it. So I did a add NaN true. So it is also telling me about this. You can also save these data set objects by using save and load if you want to load it. Obviously, these things are stored in pickle format, which is native in Python. Also, uh, another important method is plot randomization. This is quite powerful. So I just quickly write how you can do this. So I write training dataset dot plot randomization. Okay, why it is giving error? Okay, it need matplotlib. So I just quickly install this one. Okay, this matplot is installed. So I just quickly run this now. What it is plotting, I show you. It's okay, so there were some problems running this plot randomization. I actually didn't had matplot library, and then when I installed it, it asked me to restart the kernel. So what it does, it has all the encoder lengths, and it plots all the different encoder lengths which we have. So maximum we have length 30. Also, since we have provided some randomization, so if you go up, when I created, I also provided this argument randomized length. So because of this argument, it is reducing the lengths of some of the things or some of the points, and you can see there are some of 28 lengths, some are of 20 length, and between those. Okay, so we have another very important argument, which is reset overwrite value. So let me tell you how it works is, suppose you want to do an analysis and want to change a simple setting. Already you have everything and want to change simple setting. You change it, you overwrite the values, and you want to reset it back. So these two arguments, one is reset and one is set, comes handy at that point. So how does this work is, training data set dot set overwrite values, and what values you want to set. Suppose you set values to 0 for what variable. Suppose the variable you select is say promotion, and you also want on which target you want to do target, and what's this one? Target, okay, target, and you can pass the target as say decoder. So you want to do promotions to 0 for decoders, and if you run it, okay, now your training data set has set all the promotions to 0 for decoder part. And if you want to reset this, you can simply use this function and training data set, okay, training data set or reset values. Now it will reset the things. Okay, now the most important, uh, nothing can be more important than this method. This is x underscore to index. This is like superpower for debugging. It maps the model input batches back to original data frame rows. So I can show you what it does. Simply I just copy paste this. Okay, I'm not running this for now. So you have batch. Simply I have already shown you how batch looks like. Okay. So this is typical batch. You have multiple keys, and you have y, and you have weights as well. But now I want what exact index it has been matched to. So I can do it ax to index for say batch 0, and in batch 0 you can see for 16 rows you have starting time index as 34, store id as 2, and product id as p3. So this is like very helpful when it comes to practical scenarios when you want to debug things, and you can also use them in the model as well when you are calculating your loss, and suppose you want some encoder time indexes, so you can use this as well. So they are pretty much about methods. There are some attributes as well, which I guess I have already shown you while we were creating the model, and they are pretty obvious. However, I think if you just simply write training class, training data set, and dot say categoricals, you can know what categories it has. So they are more like a variable rather than the method. So you can try these one by one and read about the description. Now, one very important thing, this is a common confusion. Why don't we have weights for encoder? We have weights for decoders when we have labels like y. Okay, so when I showed you about about this, about what a best typical batch look like. So you have training data, you have labels, and you have weights, and these weights are for decoder only. You don't have any weights for encoder. So the reason is loss is actually computed only on future predictions or the decoder horizon. The encoder is only for context. We do not compute any loss on past observation. So assume when you are doing a normal training, do you compute loss on features? You only compute loss on the training labels. Here actually it gets confusing because your training data and the label data both are time series of same data point. So this is one thing which you need to keep in mind. And now I am going to show you how you can monkey patch the things. Suppose here in keys of a single training batch, you had encoder category, you have encoder continuous variables, targets, lengths, everything for decoder as well. But you have something like decoder time index, which you don't have for encoders. Okay, now suppose you are doing something and you want encoder time indexes as well. So how you can do it? Okay, I show you. For showing you that, I need to create another file, say add encoder indexes. Okay. Now first I will do the regular imports which we have. I will just copy paste some of the code from my previous notebook. Okay, I need this. Okay, I need this as well. Now I need this as well. I'm not removing any data set now because I want to show you actual thing. These small things I can also copy, but they are not required as such. Okay. Now I have a training dataset. Before creating object of training dataset, let me patch training dataset. Okay, so this is training dataset class. If you go to collate function, you go to collate function. This is the class which is responsible creating the outputs for each batch. So you have everything for encoder, everything for decoder, but not encoder length. So okay, I just copy this class. This is something which I want to change. So I just copy this. Okay. and wants to add encoder length. Okay, so in addition to decoder length, I want encoder time index, not length but indexes. So encoder time index, I want to create this. So add encoder time index. Okay. Actually, it is very tricky to write. You have to write one by one and know what each thing is doing. So I have written directly for now, and what we can do, we can start running this as well. So okay, now what we can do is change the method, change this function. So time series data set dot collate function is underscore underscore collate. This collate function, the one underscore is there, so one underscore. Okay, then static method new collate function. You need to run this again. Okay, so now monkey patching has been done. Now this time series dataset has a new collate function which is mapped to underscore collate underscore fn. So now if you do the same things, now I create this particular time series object. Now it should run, and the thing where we see in a single batch where we see, I just quickly run these things as well first. Okay, loader is also created. When we I create a single batch, error RNN is not defined. Okay, so in the base function we are using this RNN, so I need to import this as well. I have this now. Okay, how about now? Okay, it works. Now if I see keys of x dot keys, it has all the things. It has decoder, it has both encoder time indexes and decoder time indexes. So in this way you can also monkey patch this class and use it according to your needs. So this is pretty much about time series dataset and this video. In the fourth part of this series, we will start looking at the tutorials which has been already provided by PyTorch Forecasting, and starting with Temporal Fusion Transformer. I will not only explain you how you can implement it using this library, but what is actual concept of Temporal Fusion Transformer. Till then, thank you. And also before going, try implementing everything which you saw in this video on your machine as well. Dig deep in this class. Whatever you can see, time series data set, there are multiple functions, like collate function is a kind of popular function which is there in normal PyTorch as well. So till then, have a nice day and thank you.